This is where it gets easy. Basic power rule for taking derivatives. Basic power rule for taking derivatives. So this is what we're going to have. Well, first, let me remind you that the derivative is a slope, or it gives you the formula for a slope of the tangent line to any function. So remember what's tattooed to your brain. The derivative of f of x gives you a formula for the slope of the tangent line to f of x at any given x value. A lot of people on the test, they put, it's the tangent line to f prime of x. No, that's not right. It's just the tangent line to f of x. The derivative is f prime. So the derivative is not the slope of itself. The derivative is the slope of the original function. So that's important. We're going to add to this tattoo. I'm going to mention it now, but we're not going to really explain it too much. But I want to mention it so you have it written down, just so you have it for later. Oh, your tattoos are getting more colorful. Frank, I don't like that. They're old. They maybe are against tattoos. I don't know. We can also think of the derivative dy dx as the instantaneous rate of change. We talked about that, but eventually we're going to think of the derivative as a rate. So it's important just to have that in the back of your mind. Anyway, let's talk examples of the power rule. So the power rule says if you have something with an exponent, like a variable that you're taking the derivative with respect to, so I'm taking the derivative with respect to x. If I have some function involving x and it has an exponent, taking the derivative is as simple as bringing this exponent down in front. So I do that, and then taking this exponent and a minus 1, minus 1. So that would be n minus 1. That's the power rule. That's it, right there. That's it. That's it. That's it. That's all. That's it. Let's get to some examples. So find f prime. Find the derivative. Take the derivative if f of x equals x to the 5th plus x to the 3rd minus x to the negative 10. Okay. Remember, taking the derivative means you can distribute the derivative operator to all three of those things. That was from the last section. Oh, we're going to use this? We're going to build on it? Yes. So, what do? Well, I take the exponent and I bring it down, and then I subtract 1 from this exponent. So, f prime of x equals 5x. 5 minus 1 is 4. So 5x to the 4th plus, bring that one down, 3x, and then subtract 1. 2. Okay, 3x squared. Minus, take this one, bring it down. We get a negative 10x, and then negative 10 minus 1 is negative 11. That changes a little bit. 5, that's a weird 5. And there you have it. F prime of x. There it is. That's all. Cool. That's all you got to do for that. All right, let's look at another example. There's two things different about this. What is the slope of the tangent line to g of x equals 3x to the 4th when x equals 2? Well, first of all, we refer to our tattoo. Hopefully it's not on the back, because then you need a mirror. Maybe it's on your forearm. That's like cheating on tests. The derivative of f of x, so the derivative of a function, gives you a formula for the slope of the tangent line. If I had a formula, and then you could take that formula and then plug in a 2, and then you get the slope. Yeah, he's right. He's right. Admittedly. Just calm down. Don't get too cocky, kid. So, what is the slope of the tangent line when x equals 2? Well, we will take the derivative to find a formula. For the slope of the tangent line. And at any given x value. We have a given x value of 2. So let's see how to take derivative. G prime of x. Remember, if we are imagining the derivative operator d dx, we can take the 3 and move it out front. So if I do that, maybe I should write that d dx with the 3 out front of x to the 4th. Well, that's pretty easy. That's just 3 out front. We bring the 4 down, so it's like times, and then x to the 3rd, right? I subtract 1. So that's actually 12x to the 3rd. So this is the formula or the rule. In the Khan Academy assignment, it'll say rule sometimes. So that's the formula for the slope of the tangent line. All right, when x is 2, so we'll find g prime of, sorry, not x, 2. Well, now we actually have a formula. Before we had to think about the graph, but here we have a formula. We don't need to graph it. So we'll have 12 times x. No, not x. 2, right? 2 to the third, because I'm just plugging it into that formula. Well, 2 to the third is 8. And then 8 times 12 is 96. So we have a slope of 96. Slope is 96. That's really, really steep. Slope of g, that's the slope of g of x, is 96 when x equals 2. So that's just to be super explicit. So there you go for that. Maybe one more example? Oh, a couple more. Let's take a look. So example 3, what's the derivative of, well, the fourth root of x? Well, it's just square root. I don't know how. We can change it to an exponent, though. Right? That's the same thing as x to the 1/4. And then I can take this and move it down in front and then subtract 1. So here we go. Here we go. We have 1/4 x to the, well, that's just 1/4. And then if I want to subtract 1 with a common denominator, that's just subtracting 4 over 4. Remember, that's all in the exponent. Don't write it super huge. I'll write it smaller. So there we go. And then what do we have? We have 1/4 times x. Don't put your x down here. That's wrong. Well, right now it's wrong. 1 minus 4 is negative 3/4. So that if it's a negative exponent, then that's just 4x to the 3/4. And if I want to change it back to a radical, I'd have 1 over 4, and I could have, what, the fourth root of x to the third. Hopefully you understand that. Or the 3 could be on the outside there. But there you have it. That's the derivative. That's how you do that with the power rule. Last example. Actually, you may want to write this little note. Change radicals into exponents. Then you could just use the power rule. Okay, so we have a fraction here. Later on, we'll learn a quotient rule, so we don't have to do this. But right now, we can use the power rule. How do we use the power rule? We first split up the denominator. So here, I'll just have x to the fourth over x to the third minus x to the third over x to the third, and then plus 3x to the negative 2, and then just over x to the third. So then I will simplify this. This will become just x, right? When you divide, you subtract the exponents. This will become 1 minus 1, and this I'll move to the bottom, and I'll add those two, so this will be x to the fifth on the bottom. Those are just the exponent rules. Actually, instead of writing it on the bottom, I can move this up, and it'll be a negative 3. I want it in the top so I can use the power rule. So this will be 3x to the negative 5. Now I could use the power rule. So f prime of x, well, this is like a 1 there. If I bring that down, I would get 1 times x to the 1 minus 0. So that would, or no. 1 minus 1, that is 0, x to the 0. The derivative of a constant, that's just like x to the 0 already. What's the derivative of a constant? Well, we think about it like it's just a flat function, so the derivative here is 0. That's a rule that I'm going to write down after this. Same with the derivative of x, it's just 1. And then, what is this? Plus negative 15x to the negative 6. And I'll simplify this. This x to the 0, that's just 1. So this equals 1 minus 0, that goes away, and then minus 15x to the negative 6. You can leave it like that, or you can put the x to the 6th in the bottom. And there you have it. That is the derivative. Let's write down some quick rules, and then we'll be done with this 10-minute video. So the first thing is the derivative of a constant, the ddx of c equals 0 if c is a constant number. That's what we saw here. We did the derivative of -1. Yeah, that's 0. The derivative of -3, 0. Derivative of 3,782, 0. Remember, because it's the slope of the line there. And then the derivative of just x equals 1. The derivative of just the variable x equals 1. You can prove that with the power rule, but it's shorter if you just remember this. And there you go. That's the notes there. Have a good day. Do the Khan Academy assignment.